Without using a calculator, we're going to consider the following piecewise functions. So we have three different equations, an absolute value, a linear, and a quadratic, and we have the following constraints. Let's find the following values. If they don't exist, we have to explain why. So let's see, where does -1? Well, -1 is not in between -2 and 5. -1 is here. It's in between -2 and 1. So I'm going to come to this piece of the equation, and I'm going to substitute a -1. Substitute a -1 for an x value. And p of -1 is 4 plus 1. P of -1 is 5. Did you also have that? Anybody here? Yes? Okay. Let's now figure out what p of 1 is. P of 1. Okay. P of +1. Well, 1 is not in between. Well, here's a tough thing. I see a 1, and there's definitely going to be some confusion, but I can't consider this equation because the constraint says x has to be less than 1. It can't be equal to 1. So I can't consider this one. And I also can't consider this equation because the constraint says that x has to be greater than 1. That means there is nothing here. It's undefined at p of 1. And behind that, I'm going to write a hole. There's going to be a hole in the graph there. Let's get started with part B and graphing this. So I'm going to go over to the left 3 and down 5. Left 3 and down 5. This is an absolute value function. It's a V shape. If you don't see this, in front is a hidden 1 over 1. That's the slope. So I know that's symmetrical. So I'm up 1 over 1, up 1 over 1. It's looking like this. And then it's symmetrical. It's looking like this. But before I even connect those, I can see that I'm only going to graph this between -5 and -2. So in this range right here, I'm going to have a closed dot, open circle at 5, and an open circle at -2. I'll let you get caught up. Do you have any questions on that part?
Is it open circle?
Yes, it's open circle based on the constraints. Yep. So you look at the ends of the constraints, and if it has a line underneath, it means we include it, we color it in. If there's no line underneath, we leave it open circle. We don't include that point for that part of the equation. Okay, this is y equals -4x plus 1. Some of you may prefer to graph it like this, thinking it like this. I'm going to start at +1, and I'm going to drop down 4 and go right 1. Drop down 4 and right 1. And so we're going to see something like this. 1, 2, 3, 4, something like this. Okay, but then it says, the constraints say, hey, put a closed dot at -2. So I got to go one more over 1, 2, 3, 4. So closed dot at -2, I've got it, and do an open circle at +1. So this will have an open circle. All right. Okay, let's go on to the next one. So we have a quadratic function here, and this is vertex form. I'm going to go to the right 3 and drop down 5. Right 3, drop down 5. What I like about this is, remember, it's 0, 0, 1, 1. I'm going after this parent function, by the way. So 0 squared is 0. 1 squared is 1. 2 squared is 4. 3 squared is 9, and so on. So I'm going off of that. And because the leading coefficient is a 1, I don't need to multiply the outputs or the y's by any other number. So I'm able to graph. Here we go. We know it's symmetrical. This is 0, 0. I'm going to go over 1, up 1. Over 1, up 1 to both sides. I'm going to go over 2 and up 4. Over 2, up 4 to both sides. And then I'm going to go over 3, up 9. 1, 2, 3. There's up 5, 6, 7, 8, 9. But before I connect them, it says go between 1 and 6. Well, here's 1, and at 1 I need to have an open circle because there's no line underneath. And here is 6, and at 6 I need to also have an open circle there. All right. That's a lot of work. Explain how the graph of your function above validates your computations for part A. So if we go to -1, we can see that the output value is 5. That verifies it or validates it. And at positive 1, x equals positive 1, if we look up and down, we do see a hole. There is no output value. It also validates that it's undefined. Determine the domain and range, and that's going to be part D. I'm going to put it over here where we can see it. This is part D. So the range goes from when x equals -5. I'm not going to include it. Notice it's an open circle. And it goes all the way up until where there's a hole in the graph at 1. There's no output value to 1. And then it goes from 1 all the way to 6. And at 6 again we have an open circle. We have no output value. It is important that you pay attention to whether it is parentheses or brackets. Brackets means we have included output value. Let's go with the range. It goes as low as -5, and we do have an included value. And it keeps going up, all the way up to a value of 9, and it is also included. That is part D.